Brigham Young University, and this is our Data-Driven Education and Athletics Outreach. My name is McGyver Clark, and I'm an affiliate professor here at BYU. So our presentation today is we're going to talk about our new organization charts. The students are going to give a demo and showcase of their work this quarter. And then we're going to talk about what's next and then an overview of what we have accomplished as a team. So our team has been separated into two working groups. Our first is our data engineering team. We have Zarek Prophet, Nathan Brimhall, Heather Thayer, Mark Bryant, Eric Bryant, and Marcus Thayer. And then we have our second team, our app engineering team. This is Davin Thompson, Creed Thompson, Luke Grunvig, Ty Austrich, and Eric Hedengren. We also have our outreach team, and that is McKenna Power, myself, McGyver Clark, and John Hedengren, and we are in charge of the outreach. So here's just a quick demo of what we've developed so far. So this quarter, we have added a enhanced distance analysis, and this is where we have added some animation to the videos. And the students' projects, they'll talk about more of the reasoning of why we have done this. But we've made lots of different progress, and we're very excited about these new developments. The other analysis that we service is a sprint analysis. And so here we get the time that they've covered 10 meters and all of the different statistics that predict an efficient sprint. So first, we're going to give a quick update on how our outreach program is doing. So we have reached over 1,000 athletes in the 6 months that we have been doing this project, and we have visited 23 teams total. The outreach program is doing amazing. We've had lots of fun continuing to visit schools and analyzing athlete performances. We talk about engineering careers and paths to which athletes can follow so that they can do data science engineering and they can see real-life application to the innovations that we develop. The other part of our outreach programs, we are expanding it to an online educational platform. We want to touch as many people as possible with educational efforts in ways that they can use data and current best practices to increase their performance and increase their longevity as athletes. Another feature that we have added is a feedback mechanism. So after we go to visits, we ask for coaches' feedback. We have gotten some great feedback, but also it has been very helpful to get some honest feedback as well. The biggest thing that we can do to improve is increase the readability and understandability of the data. Though with that said, here by an anonymous review, they told us that it was provided a safe platform to look at how technique and strength can benefit performance. So we're appreciative of the feedback that we've gotten from our coaches. Now, part of our outreach is that we want to educate and increase the quality of training in the sport in general for youth. And so you can see here that the total number of track and field athletes reaches over 1 million athletes in the United States. Now, 20 to 40% of those runners will experience an injury, a time loss injury during that year. And this is a pain point and a problem that we want to help solve. And so that is why we've started to give some online resources so that we can scale more efficiently. And so on the roadrunner.club, we have started making a library of helpful information with tutorial videos so that more athletes can be reached outside of Utah and outside of the time constraints of the visits that we perform as well. We've had some early great success with these, and we're starting to get in the tens of thousands of views on our video educational library. But we want to increase these, and so this is part of our next initiative. Is we will employ a much larger set of training videos and helpful educational videos so that we can increase our reach and impact into athletes. So the next is the distance running analysis. So this is Nathan's project that he has worked on. He has been instrumental in what we now have deployed in our application. So what he has done is taken a total of 11 feature measurements. And these are things that PhDs and physical therapists use when they are performing gait analysis in the lab. They are things like your ground contact distance from your center of mass. You can see this in the center video, and others. And what he has done is he has taken our AI and annotated on top of it so that the user understands exactly what the data is meaning in real time on their body. Some other things that he has learned and taken away from this is he's been able to effectively annotate and animate videos, learn GitHub and how to interact with a larger code base and a larger team. Nathan actually had no Python experience prior to this project, and now what you see in our app is what he has built himself. He's been able to understand the larger aspects of the code base and the app, and was able to start to deliver data visualizations, and that will be our next implementation for our distance analysis. One aspect here is the vertical displacement, or the vertical oscillation. And this is one aspect that we have seen a large correlation in both injury and injury rates as well as performance rates. In our Lehigh High School visit was their first test visit with these new visualizations, and we were able to see a markedly different reaction from the athletes because they were able to visually see what we meant by what we said. And this is from the coaching feedback, and this is a pain point that we have been working to solve this quarter. So in the distance analysis roadmap, we've created and illustrated 11 feature videos, and we've incorporated that into the broader app. Now we are going to increase the visualizations with user averages and appropriate analytics. And then we want to add a seamless way for users to understand what they can do with that information through strength training, mobility training, etc. So Ty and Zarek have been working on our sprint analysis. So by the end of last quarter, we had a sprint analysis where we had derived many different aspects of the sprint. It was the data was very insightful. However, what we found in our visiting our 1,000 athletes was that the interpretation of the data was not intuitive for most users. And so what we have done is we have taken the framework that we built for distance analysis, and we will apply that to the sprint analysis so that we can make an easily understandable method of showing what we mean by what we say and what the data is trying to tell the user. Want to make it more digestible and want to make it easier for the end user, who is a non-technical audience, to understand. So things that they learned through this quarter was, number one, how to refactor a code base in anticipation of future features. So how can we build a scalable platform so that we can easily and efficiently create new features on top of what we've already built? Learn to contribute within a GitHub workflow, develop the skills in Python, and thinking through the development with the user in mind. Very, very key things to learn as an engineering student. Now, Luke has been doing amazing work in the importing and analysis of wearable data. So he is working on wearables, so from watch data, importing that and playing around with how can we create usable dashboards and quantify things like volume, intensity, and making work metrics so that we can then combine those two worlds with the biomechanics data to make holistic predictive models and training aids for athletes. He has made significant progress to where when someone with a watch on his system, when they post a workout or an activity, then through the Garmin API, we receive the file, we process the file, we pull the metrics, and now we are working on displaying the data in an easy to understand way. So here's a demo of the work that he has done. And so he is taking this data from its primary source at the sensor and then has researched reputable and peer-reviewed methods of quantifying intensity and work metrics, and now is creating a app infrastructure to be able to display that to the user. And here is a quick demo of the progress he has made this quarter. So why are we doing this? Number one is injury prevention. So the yearly occurrence of time loss injuries in middle distance runners is 64%, long distance runners 32%, and marathon runners is 52%. It is very, very, very high, and most injuries are due to overuse. And so what the goal is with this is give a holistic view of athletes' load and form, give coaches access to that relevant data, track the progress, and detect fatigue and improve injury prevention. Now, we had a larger team with Creed, Davin, and Luke was also on this team, and Eric. And what they did this semester independently was refactored the code base so that we can expand as a platform and as a team. So the starting point of where we were last quarter was we had about 14,000 lines of a code base contained in just 2 files. It lacked clear structure and organization. It challenged new team members to navigate. There was minimal debugging support, and it was significant time investment required for new feature development. Internally, they created a vision. They wanted to revamp the file structure with enhanced code readability. They wanted to minimize code duplication and increase flexibility for switching to new database or front ends so that we can have multiple database layers, multiple client-side front-end layers, and make it a seamless transition to as our platform expands. Their approach to restructuring the code base. Number one was first brainstorming, so collaborating with mentors to design the optimal file structure for the project. Then planned, they analyzed the code base and determined the appropriate placement for each line within the revamped file structure. And then they relocated each code segment to its designated file for the new structure and conducted thorough testing to confirm functionality and that all functions remained intact. So what was the end result was before we had about 2 files. Now we have over 60 different files. Before we had just about 150 functions, and now we have about 250 functions. And for our non-technical audience, it is best practice to have each function perform one operation in the application structure, and each group of functions to have a different file. And so what essentially they did was take 2 monster scripts and put it into organized bins so that you can find what you're looking for faster and easier. So now another byproduct of their project this quarter was a total 21% decrease in lines of code. So we went from 14,000 lines to 11,000 lines. This improves maintainability, reduces complexity, and enhances performance. So what is the why? Why did we do all this work? Well, they did this because it doubled the time of deployment of new features. So our feature velocity has doubled. And what did they take away from this? They navigated and contributed complex and unfamiliar code base, mastered GitHub for effective management of a large-scale project, collaborated and communicated effectively to maintain code integrity, and independently planned and executed tasks with minimal mentor guidance. They streamlined the onboarding process so that our new students can quickly adapt to the code base. So what is next for our application development? 1, improve technology stack. 3, increase reach and impact. And 4, accelerate and expand learning for these students. So our app structure currently is as follows. This quarter, we added the green sections. Prior to this quarter, we already had the red sections. So you can see that we did separate our front and back side, our client and server sides. We improved our Streamlit front end, and we did add a systemized and organized backend processing. Now, for our next project, we are going to add a professional and scalable app infrastructure design. Here's the new schematic of what we're going to do. We're going to migrate into a scalable database. We're going to add API endpoints into our backend processes, and that will allow us to be able to service other platforms as well as offer services to other researchers and other platforms that want to use what we have built, and we will make it accessible through API and through authentication. We're going to add a control layer, and that will allow us to service multiple different front-end clients. And we're going to end a brand new web app React-based client so that the user experience and the development process is easier, faster, and then we can work towards native app development. So for our next summer and fall of 2025, here are some of the learning outcomes that we would like to see as a project. Number one is the students are developing technical expertise, that they will acquire advanced hard skills in application development, data analysis, data visualization, mastering tools and techniques such as programming frameworks, statistical methods, and visualization libraries to build robust user-focused solutions. Number two is gain professional experience. They will obtain hands-on experience in full life cycle of application development and deployment, including design, coding, testing, and implementing, and preparing them for industry standard workflows. The third objective is to enhance soft skills. So students will cultivate essential soft skills, including teamwork, collaboration, creative problem solving, through active participation in group-based development and iterative project design. And our fourth one, which I'm very excited about, is strengthen communication abilities. They will develop the ability to effectively communicate complex technical concepts to non-technical audiences, honing skills in presenting data-driven insights and project outcomes with clarity and professionalism, and this will be done as they participate in outreach visits to the high schools. So overall, this quarter, we have doubled the efficiency to new feature development. We have 12 undergraduate researchers that are actively working and gaining experience in a real-world technology development atmosphere. We have 4 developing analysis types. 2 of them we will be releasing in the next few months. And by this quarter, we have reached over 1,000 athletes with our current infrastructure. So we would love to hear questions or comments in the comment section. And thank you so much for listening. And we are excited to keep developing as a group and help maximize the potential of athletes and minimize risks to injury, as well as develop professional and high quality students from the Brigham Young University Engineering Department. So my name is McGyver Clark again, and thanks for listening.